This video is over lesson 80, transformations, and it's for my 7th grade math class. So ladies and gentlemen, a transformation is an operation on a figure to alter its position, orientation, so which direction it's pointing, its shape, or its size. Congruence transformations, however, result in congruent figures. So congruence transformations will only change the position and the orientation. The shape and the size will stay the same. And there are 3 congruence transformations that we're going to take a look at here today. So the first one is what's known as a reflection. Or you could consider this a mirror image or a flip. So we're going to take a look at triangle DEF and we're going to reflect it. And so there's going to be a line of reflection. So the line of reflection is like a mirror. So in this case, we're going to reflect over the y-axis. So we're going to treat the y-axis here as if it was a mirror. Now the thing about mirrors is if you were to look into a mirror and hold up your hand, it will look like your reflection of your hand is the same distance away from the mirror as your hand is away from the mirror. So that if you were to touch the mirror, it would look like your reflection was touching back. So that's a key idea here. So if D is 2 units away from my line of reflection from the y-axis, then its reflection will be 2 units away, but on the other side. And we call this point D prime. We put a little tick mark above it. It's not a 1, it's actually a tick mark. So that's D prime. And then E here is 1, 2, 3 units away from my mirror, my line of reflection, the y-axis. So we go 1, 2, 3 units on the other side. And so that's E prime. And likewise, F is 1, 2 units away. So 1, 2 units on the other side. There's my F prime. Connect the dots. And it should look like we just reflected this over the y-axis. So real quick over here, triangle DEF is what is called the, is called the pre-image. So the prefix pre means before, so this is before we've done our transformation. And so we would read this right here as triangle. We have the triangle symbol there, so triangle DEF, just like it says DEF. However, this triangle right here is actually a D prime, an E prime, and an F prime. So after we've reflected it, we get all these primes. And this then is the image. So pre means before, image. So this is the image before, this is the image after. And so we would say this as triangle, because there's the triangle symbol. But then we'd say D prime, E prime, F prime. So each letter that has a prime on it, we would say the prime for each one of those. Let's go over this one here. So same triangle, but this time we're going to reflect over the y-axis. So now my mirror is going to be the y-axis. So we're thinking about how far away are we from it. So D is 1, 2 units away. So we'll go 1, 2 units on the other side. There's my D prime. E is just 1 unit away. So we'll go 1 unit on the other side. And then F is touching it. So remember that if you are touching the mirror, it looks like your reflection is touching back. So actually f and f prime are the same point. And so it should look like this was reflected over the y-axis. And it does. Now if we take a look at the coordinates here, we'll notice there's something special going on with each of these. So here, my y values are the same. So the y values on both of these is still 2. But this x value is a -2, whereas this x value is a +2. Again, the y values stay the same. But whereas this x value is a -3, this x value is a +3. And then here, my y values are the same again, but this has an x value of -2, this has an x value of +2. And so what we see is, if this is my point, the arrow here says after the transformation, what does it become? Well, the y value actually ends up staying the same. When we reflect over the y-axis, the y value stays the same. So what happens to the x value? Well, it becomes its opposite. And we express an opposite with a negative. So that a -2 becomes a +2. A -3 becomes a +3. A -2 becomes a +2. Likewise over here, it actually turns out to be the same kind of idea, but just switched around because we're going over the x-axis. So since we're going over the x-axis, the x value is the same, the x value is the same, the x, well, all of that's the same since it's touching. So the x value will stay the same, but now my y value goes from a +2 to a -2, and from a +1 to a -1. And so the y values become their opposites. So it turns out if you reflect over an axis, whatever axis you're reflecting over, that axis's values stay the same, and the other axis's values flip, which we express with a negative. We're going to take a look at a few other reflections here. Next up is a reflection over x equals -1. So x is -1 right here, but this also has a value of x equals -1. This has a value, that has a value, that has a value, where x is -1. We consider all those coordinates, x is -1. For that matter down here as well. So what we're doing, if I make a dashed line out of this, is we're saying that that vertical line is going to be our mirror this time. So if that vertical line is my mirror, then D is 1 unit away from it. So its reflection would be 1 unit on the other side. E is 1, 2 units away. So 1, 2 units on the other side would be my E prime. And then F is just a single unit away. So that puts F prime actually at the origin. And so then if I connect my dots, that should look like it was reflected over my red line there. If I have my line of reflection y equals a -1, well, this is where y is -1. This also has a value where y is -1, so does this, so does this, so does this, and there, and there, and there, and there. So again, if we do a dashed line here, that's my reflection, that's my mirror, my line of reflection. So in this case, D would be 1, 2, 3 units away, so count wherever the grid lines cross. 1, 2, 3 units away. So then 1, 2, 3 units on the other side. It is almost off my coordinate plane there. E is 1, 2 units away. So 1, 2 on the other side. And F is 1 unit away, so 1 unit on the other side is my F prime. Once again, my image looks like it is reflected over that line of reflection. They look like mirror images of each other. And the last one I'm going to throw in, this one definitely is not going to be, well, I'm pretty sure this one's not going to be in your homework at all, but it will be in the future, so I'm just going to expose it to you now. X equals, or y equals x is a special line because that means the x and y values have to be the same. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, negative 2, comma, negative 2, negative 3, comma, negative 3, negative 4, comma, negative 4. So this line actually goes in this diagonal right there. So it turns out that we're going to have to count diagonals then. So if we count diagonals, this is 1, 2 diagonals to the line of reflection. So 1, 2 diagonals on the other side would be my D prime. E is 1, 2 diagonals on that side. So 1, 2 diagonals, just keep moving through. That's my E prime. And finally F is 1 diagonal. So 1 diagonal on the other side is my F prime. And then if you can visualize it, you should be able to imagine folding this on this line of reflection and these two folding up and matching each other. And so I'm going to share with you a little secret here. It turns out that when we reflect over this line, it's special. What ends up happening is your values end up changing. So whatever used to be your X value actually will switch over to the Y value position. And whatever used to be your Y value will switch to the X value position. So whereas this point out here, E, used to be negative 3, comma 1, now it's 1, comma negative 3. So don't worry about that one too much. That's more exposure for the future. All right, we're going to flip over to our next transformation, commonly referred to as a slide. Its actual name is translation. And you can think of translation as you normally think about when you think about foreign languages. So when you translate a foreign language, you can almost think about it as sliding from one language to another. So a transformation is just a slide. So if I do a transformation of right 3 and up 2, that means I'm going to take each one of these points and follow these directions. So if I start with A, right 3, 1, 2, 3, and then up 2, 1, 2. So there's my A prime. Now for B, same directions. 1, 2, 3 to the right, and 1, 2 up. That's my B prime. B prime. Finally C, 1, 2, 3 to the right, 1, 2 up. There's my C prime. And so now if I connect these dots, it should look like the same triangle, but we just slid it right and up. If we take a look at a new one now, let's go left 1 and up 3. So left 1, 1, 2, 3 up. So that's my A prime. B, left 1, 1, 2, 3 up. There's my B prime. And C, left 1, 1, 2, 3 up. So it actually turns out that A is my C prime. And once again, it should look like we just slid that over. And last one, we're going to go right 4 and down 2. So 1, 2, 3, 4 to the right, and 1, 2 down. That's my A prime. So B, 1, 2, 3, 4 to the right, and 1, 2 down. So that's my B prime. Finally C, 1, 2, 3, 4 to the right, and 1, 2 down. There's my C prime. And connect the dots. And that, ladies and gentlemen, is a transformation. So our last congruence transformation, commonly referred to as a turn or spin, is officially a rotation. Officially a rotation. And something we need to understand about rotations is clockwise is actually negative. So where it would seem natural to us to say rotating this way is positive, it's not. In mathematics, that's actually considered a negative rotation. Clockwise is a negative rotation. So counter clockwise is the positive rotation. So over here, if it says 90 degrees around the origin is just going to make our life a lot easier because it means that we can pretend as if we're sticking our pencil or our pen right there, and then that just stays in place, and then the rest of the world rotates around it. Okay, so it's actually going to make our lives a bit easier here. So we're going to rotate this 90 degrees around the origin. So 90 degrees is positive, so clockwise would be going this way. So since positive, we're going to go that way. So that means we're going to put it over here. And I'll show you a little trick here, actually, to make this hopefully really easy for you. So if you imagine going from here, from the origin, because that's where we're rotating around, so from the origin, and now I want to go up to, let's say, J. So I'd go 1 to the right and 1, 2 up. So keep that in mind, 1 right, 2 up. So now what I'm going to do is I'm going to rotate my paper 90 degrees. So this space where it's supposed to be is now kind of like that space that it used to be in. And now I'm going to do the same thing that we said here. I'm going to go 1 right and 2 up. So for my rotated location, I'm going to do exactly what we did over there. So 1 right and 2 up. So that, ladies and gentlemen, is my J prime. Now to get to L, I have to go 1 right and 1 up. So 1 right, 1 up. So I'm going to rotate it, and I'm going to go 1 right and 1 up. So that's my L prime. And then finally, to find K, I have to go 1, 2, 3 to the right and 1 up. So 3 right, 1 up. So rotate my paper, and I go 1, 2, 3 to the right and 1 up. That is my K prime. Connect the dots. And it should look like the same triangle, just rotated 90 degrees. So if I go a negative 90 degrees, negative is going to say clockwise. So clockwise would say I'm going from this, we call this a quadrant. So I'm going from this quadrant down to that quadrant. So I'm going to rotate my paper so that that quadrant takes the place of where my triangle used to be. So remember that to find J, we went 1 to the right and 2 up. To find L, I went 1 to the right and 1 up. And to find K, I went 1, 2, 3 to the right and 1 up. So there's my J prime, my L prime, and my K prime. (180 degrees is just 90 and then 90 again. So that'd be 90, that'd be another 90. So I'm going to rotate my paper so this is in the position that that used to be in. So it turns out that turns the paper all the way upside down. So now remember that J was 1 to the right and 2 up. L was 1 to the right and 1 up. And K was 1, 2, 3 to the right and 1 up. Put it back to put your labels on. So this was my J prime, this is my L prime, and this is my K prime. And connect the dots. It's a 180 degree rotation. Now more than likely you're going to be faced with rotating around the origin, so you're going to do what we did here, but just for good measure, we don't have to rotate around the origin. This time we're going to rotate around the point L. And so what you're going to imagine is that point L is going to stay in place, and then the rest of your paper is going to rotate appropriately. So since it's 90 degrees, it's actually going to put me in this position here. So to figure out where everything goes, now obviously L is going to stay L. So L and L prime are going to be the same. To find J though, I'm going from L 1 unit up. So when I rotate it, if I go 1 unit up, that's going to be my J prime. Now, remember we're going around L. So from L to get to K, we have to go 2 to the right. So when I rotate it, I'm going to rotate a little more, then I go 1, 2 to the right. That's going to be my K prime. Oop, not L, K. And so I can connect my dots. And so that would be rotating 90 degrees around L. Flip the page over, and we have our last transformation. But this is not a congruence transformation, so you can see there I have not congruent. And this is what's known as a stretch or a dilation. And so there's a couple ways that we can find a dilation. And one of the easiest ways to do it is if we have a coordinate plane like this, and we know the scale factor, and usually it's going to be from the origin. That makes my life very easy. If it's from the origin, this is very simple. So if M has coordinates 1, 3, then to find M prime, well, all you got to do is use your scale factor. So the scale factor is 3, so it's going to be times 3 to each of these. So my new point will be 3, 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is my M prime. So then for N is at the point 1, 1. So therefore N prime, again, multiply those both by 3. N prime, though, will be at 3, 3. So 1, 2, 3, 1, 2, 3. That's my N prime. And last one, finally, O. O is at 1, 2, 0. So 2, 0. Multiply those both by 3. 2 times 3 is 6, and 3 times 0 is 0. So 1, 2, 3, 4, 5, 6, 0. That's my O prime. So now if we connect the dots, it should look like we took this smaller triangle, and we just stretched it out to being 3 times bigger than it used to be. And that's a dilation. So when it's around the origin, you can just take your scale factor and multiply both your coordinates by it. Now what happens if all we have is a grid, though? We don't have a coordinate plane, we just have a grid. And so I have a dot, a center for my dilation. I have a scale factor, so I know how much bigger it's getting, but that's all I've got. Well, it's really quite simple. If we consider from this dot how to get to this point. So imagine the lines on this grid are like the streets in a city. So I could go 1 to the right and 1 up to get there. Well, with a scale factor of 2, we're just going to multiply those both by 2. So its image then will be, instead of 1 to the right, will be 2 to the right, and instead of 1 up will be 2 up. This point down here, maybe we go down 1 and right 1. So then I'm going to multiply those both by 2, so I'm going to go down 2 and right 2. To get to here, I'm going to go 1, 2, 3, 4 to the right, and up 1. So multiply those both by 2. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 to the right, and 1, 2 up. And then finally, 1, 2, 3, 4 to the right and 1 down. So if I multiply those both by 2, it'll be 1, 2, 3, 4, 5, 6, 7, 8 to the right and 1, 2 down. And so if I connect these dots here, we end up with a rectangle that is twice as big as the original rectangle. And that, ladies and gentlemen, is the end of that lesson.